This is the screencast for section 4.4, example 2. The period of a sinusoid is much like the period of your day. You go to a class and every 51 minutes this cycle repeats itself. So the period of a sinusoid is how often the cycle repeats itself. The natural period of sine and cosine are both 2 pi. Now your book has a way of memorizing what the period is, but if you understand what is happening to the transformations, you don't need to memorize any formula. You just know what is happening to the natural period of the sine curve. So in part A, in example 2, we're supposed to find the period of each function and use the language of transformations to describe how the graphs are related. Alright, so I graphed sine of x using the same window. I graphed actually all three, but we're going to turn on sine of x only right now. Using the same window as last time, my x-min was negative 2 pi, my x-max was positive 2 pi, and then my y-min and y-max are both 5 and negative 5. So there's my graph. Now here's the sine curve. Plain old sine curve, no changes, so I don't really need to describe this with any transformations. The period of the sine curve, now watch this. One period is not just this. That's not a full cycle yet. The period is when it goes up and down and starts to repeat itself. So this would be one period, and then this would be another period. So this cycle repeats every 2 pi. Remember, this goes from negative 2 pi to 2 pi. I set my x-min and x-max. So if this is negative 2 pi to 0 and 0 to 2 pi, the stretch is 2 pi long. So the natural period of sine is 2 pi. Now, in y2, yeah, we've got a vertical, let's see. Well, I'm going to describe my horizontals first, just out of habit here. So we got a horizontal shrink. No. You know what? I'm going to write this out so it's easier to see. I have the sine of 1/3 x. Now multiplying by 1/3, it looks like it should be shrinking, but it's not. It's actually going to be a stretch out. So we're going to say this is a horizontal stretch by 3, the reciprocal. Then we've got our vertical stretch by 2 and a vertical flip over the x-axis. So in looking at that graph, so let's turn on y2. You know what? I can't even see how far this stretches, how far it takes to finish a period. But I can tell you how long it does. So this is stretched out horizontally and vertically actually, but it's stretched out 3 times as large. So if the original period was 2 pi, now the period is going to be 2 pi times 3, so the period is going to be 6 pi. It's going to take 6 pi for this cycle to repeat itself again because of the horizontal stretch by 3. Now in y3, I've got a, let's see, horizontal flip over the x-axis, y-axis, which isn't going to affect the period at all. The length of time it's going to take to recycle itself doesn't change, it's just in a different spot. No big deal. Now the horizontal shrink by 1/2 sure is going to affect the period. The period is now not 2 pi, but only half that pi. And then I've got a horizontal flip over the y-axis. So let's graph that. As you can see, that vertical stretch is there. Now this graph is shrunken in. This guy only takes a little bit of time. Whoop, right there. So only half of what it used to. The sine curve stretched all the way out before it repeated itself, all the way out from 0 to 2 pi. This guy goes from 0 to pi. So its period is pi. Now try problem number 9. Says, find the period of the function and use the language of transformations to describe how the graph of the function is related to the graph of y equals cosine of x. Well, there's two transformations taking place here. There is a horizontal flip over the y-axis, which is not going to affect the period at all. It's going to flip the graph around, but it's not going to change how much time it takes for this cycle to repeat itself. The other change will. That is a horizontal shrink by 1/7. So instead of this graph taking up 2 pi to repeat itself, it's going to shrink by 1/7, which means its its period is going to be 1/7 times 2 pi, which is going to be 2 pi over 7. I know that's a weird number, but it just means it's going to be shrunk. Basically, there's going to be 7 repetitions between 0 and 2 pi, unlike the natural cosine curve where there would only be 1 between 0 and 2 pi. So let's look at that graph. Look at that. That is, it's so tiny. So we've got 1, 2, 3, 4, 5, 6, 7 repetitions between 0 and 2 pi, which means if there's 7 of them stretching over here, the period is 2 pi over 7.